Good morning, good evening, wherever you are. Welcome to our fourth training session related to the Transatlantic AI Hackathon. The German-American Business Association is happy to present the hackathon on health and safety monitoring, together with EIT Digital and with Intel and Luxonis, our platinum sponsors, who do this valuable training leading up to the hackathon today in its last edition. I'm Michaela Balek, GABA's Executive Director. Today we will hear again from Jason Burris from Intel, this time about the Intel DevCloud for the Edge and other easy-to-use AI models from Intel Open Model Zoo, which you can use to deploy to your power-efficient Luxonis DepthAI camera. And actually, that is true what I just said. It can be yours because each Transatlantic AI Hackathon participant will receive the Luxonis Spatial AI camera board, provided your project gets submitted and you will be part of one of these about 15 teams. So Jay, please give a quick introduction of yourself and get started.
Thank you, Michaela. This is Jay Burris. I'm here again. I'm so excited for today's talk on our DevCloud. So it's a cloud environment called the Intel DevCloud for the Edge. Also, my colleague, Eric Kolkaj, has been through this with me and in these sessions. He's from Luxonis and also will be helping throughout the hackathon as a mentor in using the Luxonis equipment and the Luxonis DepthAI software, which complements the Intel software of OpenVINO in our cloud environment. So just as a reminder, the training sessions we have available. So the first extensive training session we did was on July 28th. It's available on demand. It was the high-level overview of the OpenVINO toolkit, as well as how it connects to the Luxonis equipment, which is Intel-based using the Movidius Myriad X chipset. On August 4th, Luxonis's Eric led this webinar talking about the Luxonis DepthAI platform, meaning the equipment and the DepthAI software, all its capabilities, and how profoundly impactful it is as a smart AI capable, depth capable camera and capable of being completely embedded as well. On August 11th, we did a deep dive of the OpenVINO toolkit, as well as in conjunction with the Intel Open Model Zoo, which is a GitHub repository of over 200 available Intel pre-trained models and public models, so AI models that you can start with in doing development, as well as we touched on topics of available applications, demo applications, and reference applications you could look through, and you could really sort of harness the coding and adapt to maybe a solution that you want to develop for this hackathon. Today, we're going to cover the Intel DevCloud for the Edge. It's a developer environment, completely free, accessible 24/7 from anywhere in the world. So just as a reminder, Michaela talked about this, every participant who's selected to be part of the hackathon will receive one DepthAI OakD IoT40 device. This is a multi-camera device. It has one color camera in the middle and then two black and white cameras on the sides for depth capability. So it can do computer vision, so feature tracking, motion estimation, edge detection, and so forth. It can also do AI, so neural network inference, because it uses the Intel Movidius Myriad X chipset for that neural network inference acceleration. It's OpenVINO compatible. You can do spatial sensing, so like a disparity depth and so forth. And then it's very small size and weight. It has a low power and low cost, but it's not going to cost anybody in terms of who participates in the hackathon. It's a far better solution than what we see on the market today, which would be lots of discrete components, which would lead to higher power draw, would be bulkier in form factor, and really would be very bespoke design. So it's very compact, very embedded. You can see it there next to the size of an American quarter. So a little bit of a reminder, you can really deploy AI in minutes through this workflow. We kind of talked about this in the first webinar, and I'm really kind of tie it all back together, particularly today, as I go through the Intel DevCloud for the edge. So number one, a couple of webinars ago, we talked about the Intel Open Model Zoo, which has over 200 pre-trained models, Intel pre-trained and public pre-trained models. So we source models from the industry, from academia, who have done research and published on them. And we've validated that they work with OpenVINO, and we have published them to GitHub with permission. They can do things like object detection, recognition, semantic and instance segmentation, human pose estimation, which I showed in the last webinar, and I'll continue that demonstration today, and other capabilities as well. You can use these and you can download them from the Intel DevCloud for the edge. So you can use OpenVINO on your Intel-based laptop, and you can use OpenVINO in the Intel DevCloud for the edge because it's pre-installed there, the latest version always available. There's Jupyter notebooks in the DevCloud that you can learn from. You can upload your models and your data sets. You can also download your data and your code that you develop there to your own local device, and I'll show you how to do that in the DevCloud today. You can develop the inference engine blob that's needed for the Luxonis device. So you can download that to your host, and I'll show you how to do that as well today, and then you can deploy that to your Luxonis device, which again, you can do depth, color camera, AI, and computer vision processing, and the device that we'll supply can operate as connected to another single board computer or your laptop through USB, or you can operate in standalone. Now, as a reminder, the workflow for Luxonis is a little bit different, a bit simpler because it's a very specific device than using OpenVINO, which I'll show you next. But number one, you can use an Open Model Zoo model. You can download a pre-trained FP16 version. I remind you that you need to use the FP16 because the MyriadX chipset requires that format. It stands for floating point 16. It's sort of a different quantization, or rather a different size of model. And in the industry, there's different sizes, FP32, FP16, Int8, Int11, and so forth. You'll use the FP16. We have models typically for both FP16 and FP32. Or you can optimize your own model, and maybe if you train a model somewhere else in another cloud service or on your own local host PC, you can use the model optimizer from OpenVINO, which outputs the intermediate representation, a .bin and a .xml. You use the Myriad compile capability within OpenVINO, and you can do this in the DevCloud, or you can do this locally when you download and install OpenVINO on your laptop to create and compile that inference engine blob. Then you set the blob path in an application that you develop. And I'm going to show you examples of sort of experiments, what Luxonis calls DepthAI experiments, really sample applications that essentially import and set the blob path, and then you can observe the action, the inference action in place. There's two great articles to look to, so that you can look to the one on the left to run Luxonis's DepthAI default models, or the one to the right where you can learn a little bit more about how to run Intel pre-trained models or public models. The OpenVINO inference engine, the API workflow, is a little bit more complex in that it services the range of Intel devices that we have on the market, the compute form factors, if you will. in a couple of webinars ago, explained that OpenVINO supports Intel CPUs, Intel integrated GPUs and discrete GPUs, and the VPUs, which is the Intel Myriad X chipset. That stands for Vision Processing Unit. The inference engine workflow for OpenVINO is slightly different than the one for Luxonis, because theirs is a more specific device, so they can control the form factor a little bit more, and they've made it been able to make it a little bit easier. And that's why we selected this device for this hackathon. But it's still important to be able to know the inference engine API workflow. So first you start out by creating an inference engine core object. Then you read the intermediate representation, so using an API of IE read network. You prepare the inputs and the output formats. So it says input blob and output blob. This is kind of the similar way with Luxonis. And in OpenVINO, this is sort of that step where the blob is created, it's prepared. Then you load the network onto the device. You prepare the input frame, meaning the images or the video, and a video is really just a string of images. You prepare the frame for how the model expects the input to be, meaning the image sizes, if it's RGB, BRG, and you may have to prepare that input frame and modify it using OpenCV, which is the open source computer vision library. You may need to resize it, transpose it, or reshape it. And then you really run the inference with the exec inference infer command. And you process the results, and that becomes a loop inference. When you think about an embedded device, and in the webinars that I've hosted, the classic example I've made is think about a smart doorbell at your front door. That device is very much an embedded device. It's programmed essentially once, and it is, you tack it up onto your wall outside your front door, and it is constantly running, looking for people to come into frame. And then the applications on that kind of device typically send a notification or an alert to a smartphone app on the homeowner's telephone, on usually their mobile phone, right? To say, somebody's come to your door, we've noticed this activity, view the video, and potentially you can speak through a speaker, maybe that's on the smart doorbell. So that's really what kind of embedded means. It's sort of set it and forget it. And it's running over and over again, just constantly looking for somebody to come into frame. Now, Luxonis has a lot of what they call DepthAI Jupyter Notebook experiences. I'm going to take you there, but 4 examples that might be really interesting to you for the purposes of the hackathon that you may want to build upon, modify. Number 1, mask detection. So they have an experiment there that shows mask detection. There's one for social distancing. So determining how many people are in frame and how close they are, and if they are social distancing or if they're too close. Text detection. You may want to use text detection in a health and safety use case, maybe reading labels on prescriptions. I don't know. There could be a lot of use cases for text detection and inputting that text for some extensive use of an application that you make. And then gaze detection and many more other DepthAI experiments are there. You can find them on github.com/Luxonis/DepthAI-experiments. So why don't we go there now? So at this GitHub website, the DepthAI experiments are all here, and you can see a whole long, very long list of experiments. So human pose, I'm going to show you today, but mask detection is there. I mentioned that. OCR stands for optical character recognition, so that's that text detection one. Fire detection, fatigue detection, face detection, lots of different ones available here. People counters, pedestrian identification, and many, many more. And all of these typically come with a README file that you can read a little bit on that particular one. So a little bit further down, you'll see some highlights of these, like gaze estimation. This one is a subpixel and depth disparity check, age and gender recognition available. This is the optical character recognition pipeline one, and pedestrian re-identification, and then the mask, no mask detector, and social distancing below that. So I'm going to go back up and find human pose. So here I am in the human pose estimation experiment. And you can see they have a number of files available. A little bit of tutorial on how to get started, but I'm going to show you a little bit more, maybe make it a little bit easier. So there's a little bit of pre-install that you'll want to do. Some of the, I think the previous webinar, I showed you how to sort of set up the Luxonis environment. And so this is a continuation of that. And this explains the usages of the main.py. And you'll want to essentially grab those files and pull them down or create copies of them. And if you wanted to use the device with the, if they supply an input video, you can do that. Or if you have the device, and the participants will, you can plug in the device and you can use the device yourself. And I have one here that I'm going to show you. But going back up to the top, so there's a number of files here. Starting off, the input, this little video, if you wanted to use that, you can click here, and then you can also just download it. And that'll just download it to your, typically, if you're on a Windows machine, for example, your downloads file. There are now 3 sort of text-based files. And if you open each one of them, you'll see the text, essentially the code for these. Now, what I would recommend is, and what I've already sort of done is, I have developed a directory called human pose, and I have created each of these files. You could start by copying another Python file if you wanted, or a text file, and end it with .py. And essentially, you could go in to the file, even if it was empty, and you could go edit, and you can see all the code is already in here. But let's just say it was an empty file. You could just go here and copy and paste, Control C, or right click and copy, and go back to your file. And let's just say it was empty, and go Control V. So after you've done that for all of these files, so the pose file as well, then the requirements file, just 3 lines in that, then you'll have all of those set up directly. Okay, so now a couple of other things that you'll need, and I'm going to walk you through main. Okay, so this code specifies, like say, FP16. Remember, you'll want to use an FP16 model. It's essentially telling the camera what to do, the neural network, and down here, this area is where the blob file is specified. Now, this code is already sort of pre-developed for you using this file. Actually, the pre-developed one online, let me show you that one because I modified this. The pre-developed one is linking to the assumption of a blob file called human pose estimation. 0001 OpenVINO 21.2 6shaves.blob in a models directory. What I've done is I've just modified it in preparation for this webinar to just human pose estimation. So after you've done sort of setting up your experiment with all of these files, you'll need to grab the blob files. And now I'm going to show you a bit of how to do that in DevCloud. Okay, so let's come back to a little bit more on DevCloud. So just as a reminder, the Intel DevCloud for the Edge is a free AI inference lab at your fingertips for all your projects. So there's no fees, there's no budget required, no shipping of hardware and setup and maintenance. It always has OpenVINO installed. There's Jupyter notebooks inside the DevCloud that you can learn from, so real world sample applications and tutorials. You can prototype on a range of hardware. We have hardware connected in there that's edge hardware for Intel, based on Intel CPU, Intel integrated GPU, and our VPU as well. And you can customize your applications right there. You can upload your own data sets and models. You could also use OpenVINO to download the pre-trained models, and I'll show you how to do that. But essentially how it works is you log in through a website. You can Google Intel DevCloud for the Edge, and you'll very easily find it. You just register for access. You get 90 days of access free, like I said, and you can always extend. It connects to a development server. That's kind of where, in some ways, the storage is held for you for your up to 50 gigs of private storage space, where you can upload your data sets, your own Jupyter notebooks. You can do all your coding. And after you do your coding, you can execute jobs to edge equipment that's available in the hardware, or available in the DevCloud. And you can essentially benchmark and see how quickly your application performs on CPU versus GPU versus VPU. But there's some other capabilities that, because OpenVINO is pre-installed there, that you can do, such as downloading pre-trained models and using that myriad compile capability to create an inference engine blob. So let's go to the DevCloud. Okay. So here I am at the home page for the Intel DevCloud for the Edge. I'm going to help you navigate through here a little. You'll notice it says My Intel up at the top, but if you weren't signed in, it would say sign in, and you can do that by just clicking there. If you're not registered, you can register. If you are nearing the end of your 90 days, you can extend access as well. On the home page, gives you a little indication of what you can learn, what you can build, how you can also optimize applications, and really launch applications as well. You'll find other things like testimonials, solution briefs, and additional videos. Now on the Learn tab, we have some great getting started tutorials, and these are Jupyter Notebook tutorials. The power of Jupyter Notebook is that it's executable code surrounded by written narrative explaining the tutorial, explaining and teaching you what's going on. Again, you'll see the same overview if you don't want to go rewatch this webinar, but you'll find it here. And you can also find all the range of types of equipment that we have in the DevCloud if you do so want to try to execute your application and see how it performs differently on CPU versus GPU versus VPU. You can see, Intel offers a range of SKUs of chipsets in the CPU range, typically starting at the smallest, an Intel Atom, up through Core, i5, i7, i9, and then Intel Xeon, which is very beefy, typically used in edge servers or even in data centers. GPUs, Intel now has discrete graphics, but we have right now integrated graphics capability built inside of CPUs. Because when you have an Intel-based laptop, you're using an integrated CPU, you're using a CPU that has an integrated GPU in it typically. Also, we have accelerators, what we call accelerators. We call our Intel Movidius Myriad X VPU, Vision Processing Unit, an accelerator. And the reason why we call that an accelerator is because it's typically used as maybe an add-on to a compute device, a board that may already have a CPU, and adds on a device that has the VPU on it, such as an Intel Neural Compute Stick 2. But we also offer examples of PCI Express and other form factor daughter cards that slot into edge servers and devices to add that extra accelerator capability. If you ever wanted to see all the hardware configurations, you could click on this link. So if you scroll down, you'll see all the different, these are physical pieces of hardware connected in the cloud that you can run jobs to. So different versions of Core i5 with different versions of, say, HD graphics. You can extend this and show more. So 530 versus 630 and many more. Here's one that has, this particular device has an Intel Atom CPU that includes integrated graphics, HD 505, and then also Movidius Myriad X accelerator design card. So like a PCIe type daughter card. So going back to learn. If you go to the tutorials, you will find tutorials for classification, object detection, style transfer, how to migrate to the DevCloud, which is uploading your own data sets or models, how to migrate to the edge, meaning how to download your data from the DevCloud, an OpenCV tutorial as well. All of these are Jupyter notebooks. And I'm going to show you, let's just go to, say, classification here. So it'll start a Jupyter notebook environment. You can see it says Jupyter notebook. And now you can see, and you can reduce the size of the contents, and you can see how there's all this sort of narrative text that's explaining what's going on. And again, a reintroduction of what OpenVINO does and how to use it. And then you'll get to portions of executable code. So these sort of gray boxes are executable code, where you just execute by hitting the sort of run this cell, and you can just continue on. So it's an imported Python module successfully. Download, in this particular example, it's downloading a model called SqueezeNet 1.1. You can see it's downloading, and then you can also convert. And so the conversion process is using OpenVINO to use the model optimizer. So you're model optimizing this SqueezeNet 1.1 model to output the intermediate representation files, the .bin and the .xml. So it converted this IR to FP16, and it created, and it'll list here the locations of these. So where your file now lives, when you downloaded it, and so forth. Further down, so this is the classic example of using OpenVINO, setting up code, parameters of what the XML is, and this is where it downloaded that file to locally, not locally, but in the DevCloud, not locally to your local PC. You can continue through this. This particular Jupyter notebook explains how you're using an image of a dog. It's setting the device to CPU in this case because you're running it on the development server, but you can ultimately change that to run it on other jobs. I'm going to show you some of the documentation of how to execute a job to the edge equipment. But further down, then you are creating the inference engine core, and then you're loading the IR files. And then you are essentially executing the inference engine. And then loading the labels file. In this case, SqueezeNet 1.1 is a classification model. Classification AI is the type of computer vision deep learning model that is trained on a certain set of objects. And this particular model, I think, maybe it's 1,000 different types of objects from different types of fruit and animals and all sorts of things. And the labels file will tell you what the objects are, and it sort of maps that to correspond so that you can process the output in the end. So you prepare the input, which is you're loading the image of the dog that we previously talked about. You're using OpenCV to resize, transpose, and reshape according to how the model needs it to be resized. And there's the image of the dog, and it plotted out this image, and you can start the inference. So inference was complete, and the runtime took a little over 18 milliseconds. Then you can process and display the results. And in this case, it's telling you that with this image of a dog, that it's, well, this model, it says it's certain probabilities of either Chihuahua, Husky, dog or Husky, and so forth. All depends on the accuracy of the model. It's just a one particular model that you can use. You can also run different images. So we provide several other images like cat, and then you can also run your own. So if you want to set the input path to somewhere else, or you want to upload an image to your Jupyter Notebook, you can do that. Okay, now to get back to sort of the main area of the DevCloud, you just go hit this Back to Intel button. You'll find documentation for the DevCloud under the Build tab. You'll also find AI sample applications and Connect and Create. But first, let me show you sort of a little bit below. Developer documentation is on the Build tab. So this documentation here talks about the development environment itself. So kind of how to upload and download documentation, how to also start a terminal window. You can read up on documentation on how to run your code and then manage jobs. So really, if you want to execute jobs to the edge equipment connected in the DevCloud. And then, of course, security best practices, because security is quite important. Let's talk a little bit about the development environment and open up this documentation. So here's a section that talks about how to upload and download files. It's actually really easy, and I'll show you in a minute. You can also start a Linux terminal window. There are external sources available, and many other things. So now if I go back to my Jupyter notebooks, because I also have a Jupyter notebook environment running. Let's say I want to upload. The upload button is right here. So you could click it and you could just find and search your PC to upload documentation. Let's just say you wanted to select a file to download. So I just have a number of files in here already. I just click on one and the download button becomes available. And if you click this, it will just download typically to, like on a Windows PC, to your downloads folder. If you wanted to start a new terminal, you could go new. And what I'd recommend is using the latest 2021.4. LTS stands for long-term support. That's a new Jupyter notebook, sorry. And then the terminal button is here. So I'm starting a new terminal window, and it works based on Linux. It's not a Windows environment in the DevCloud. So typical Windows commands, VI, those kinds of things work. And you could do ls, and you're right here at the same place, just in a terminal window. I'm going to come back to this and show you why this is important. So let's just say you wanted to start and create a new Jupyter notebook. You go to new, like I said, Python uses Python 3, 2021.4, and you can start a new Jupyter notebook this way. Now it's empty, but there's, you can fill this up with written text. You can also fill it up with code. And I'm going to show you some easy widgets to use to try to get started. So number one, what I'd say is start with this code snippets here. We have a number of available types of code snippets to get started with, like app snippets, model snippets, job snippets. Let's see, I think in the app snippets and over here in Inference Engine, we provide some standard sort of code snippets if you're wanting to build up an Inference Engine application code using the DevCloud. You'll have to modify it because it's just sort of pre-canned snippets. They'll do require some modification, but it helps give you a structure to start off with. Like the first thing is initializing an IE core, and then creating a network using from the intermediate representation, IR, loading it and running it. The first thing I'm going to show you really is in model snippets. And you want to list the available models that you could download. Just add that. And this is ready to go as is. So if I execute this, it now gives you a full list of all the available models that you can download. Lots and lots of Intel and public pre-trained models that do lots of different things, as you can see. Vehicle, text, person detection, there's different models for classification, there's style transfer, all sorts of things. Now, for the purposes of this demo, I am going to be using human pose. So I'm going to find human pose estimation. There's a number of them, but I'm going to couple it with Luxonis DepthAI experiment for human pose. And their experiment uses this 0001 version of the model. I'm just going to copy this particular text. Now, let's say I want to add another sort of section to run more code in. I can go to insert and add a cell above or below, and I'm going to add one below. So now I have another new one. And I'm going to go back to code snippets and the model snippets and to download a model. So this inserts this is commented code. It is saying that, it's what the model name, it'll set up a variable for output directory, and then you have your model name. And in this pre-canned code, it's saying it's going to download person, vehicle, bike, detection, crossroad, so forth, and the model. And it uses this command. So all these commands start off with a bang or an exclamation point. And notice how it's located at this tool. It's a Python downloader tool called downloader.py. And it's going to just use the parameter of name for model name, which is set here, and then the output directory of models. So I'm going to change this to the human pose estimation. So I've done that, and now I'm going to execute it. And so now you can see it's downloading the FP32 version of the XML and bin file, the FP16 version as well, and then there's another FP16 to int8 version. And the one that is most important to me is the FP16 version XML file, which is needed. And you can see that it's downloaded to models, Intel, human pose, estimation. Okay, now let's just say you want to run the compile tool. because you've downloaded that model. I'm going to insert yet another cell, empty cell below. And I'm going to start building up a command to run the compile tool. But I need to find the compile tool first. So I'm going to go back to my terminal window. Now, this text here tells me that OpenVINO is installed at this location of opt Intel OpenVINO deployment tools. But I'm not in that location, right? I'm in my own sort of ideal location. So I'm going to change directory to opt. If I do ls, you can see the Intel directory. Another ls. I'm going to change into OpenVINO. The difference between OpenVINO and OpenVINO 2021 is it's really just I think a link to the same. So I'm really choosing 2021. And now you see the deployments tools directory. In here, this is a full install of OpenVINO. If you were to install this on your local PC, you'll have a very similar installation. It might not say opt Intel. It might say users, in my case, users, JM Burris, and then actually it would typically install to an Intel directory under program files. But knowing that it's here, I'm going to go into deployment tools. And then within here is another directory called tools. Also in this directory, you'll find other things for the inference engine, a demo folder, which is when you do the OpenVINO install, it's the initial demos to help you verify that you have installed OpenVINO correctly. The Open Model Zoo directory will take you to the Open Model Zoo models and demos. But I'm going to go into tools. And then there's a compile tool directory here, and that's where that tool is located that I want to find. There's other tools available with OpenVINO, like a benchmark tool. There's a cross-check tool. There's a deployment manager if you want to then deploy a package, build a package and deploy it after you've developed your application. Post is post-training optimization training. And then we have a GUI workbench tool called Workbench. I'm going to go into compile. And now I can see that the compile tool is here. And it is located at this location. So I'm going to copy that location. Okay, now I'm going to go back and reread the Luxonis DepthAI documentation on how to compile and run essentially a model. In this article, again, it was some of the slides I showed you. It takes you to this particular article that talks about running the compile tool and the command that you'll use. And so I am going to sort of copy and paste that text. And it's not going to be fully complete. But you can see it's essentially they're giving you a standard command, but it needs to be modified for the location of the compile tool. The -m is the location of the XML file. So you'll need to modify that. Then they're using some additional optional flags like the input and output, and they're specifying to Myriad, which is compiling this for the Myriad XVPU. The number of shaves and CMX slices really corresponds to the amount of shave cores that are available to you on the Mobidius Myriad X chipset. There's 16 available. It's typically really 13 available because a few need to be reserved for other resources. But they're specifying it with 4. I may do 6, but I'm going to copy this. And I'm going to go back to my Jupyter notebook where I've entered in this blank cell. And I'm just going to cut and paste it here. But I know I need to modify it. First, I need to modify it for the actual location of the compile tool, because if I run it, it says syntax error. So I know that because I found it, it's located here. So I'm going to copy that, and I am going to paste that. I also know that I need to add a bang because that makes it executable. Now I need to modify this to actually specify the location file. Because again, if I run this, it's going to try to run and it's not going to find this file. It says unknown arguments. But I know that I downloaded this XML to this location. So I'm going to copy that text and I'm going to insert it there. Now I'm going to try to run this. Okay, and it's still running, and it'll give an output. It took time elapsed was a certain amount of milliseconds. And that file is now available to me in my Jupyter notebook. So there's a blob here, seconds ago was created. Again, if I wanted to download this, I check on this, and I just download the file, and it will download to my local machine, typically in a downloads file. I would copy that over, and I would put that into the location where I put the experiment files, where I created them from the Jupyter Notebook experiments on GitHub. Now, if I, let's see, it's here now. I have my human pose blob. Let's just make sure that I have edited my file correctly. Okay, there it is. And I remembered I re-edited my file to human pose estimation 0001.blob. So that file is all ready for me to go. Now, if you recall, on the Jupyter Notebook for this, if I want to run this with an input file of this, or run it live with a camera, which I have one sitting here, I can. And I use it with these commands. So to get there, you can just open up a CMD command and navigate to the location where you have installed it. So I have put that into this location of, I've created a, in the install of the Luxonis DepthAI software, I have it created at my user home directory, oakd/DepthAI location. That is in the previous webinar that we talked about, so you can go back and re-review that. I created a DepthAI tutorials practice folder, and I also created a human pose folder. And you can see all those same files. It's really the same as looking at it through this version. And I also have downloaded the input.mp4 file. So if I want to run that, I can just do Python main. Now the command in the experiment says Python 3. This is really written for Linux, but this works with Windows as well. And I'm on a Windows machine right now. So I would just slightly modify this to be .py/vid ./input.mp4. And there you go. So you can see the camera here I have positioned. It's one of Luxonis's DepthAI capable cameras, very similar to the one that you'll receive as part of the hackathon. And it's running this human pose estimation. It's giving you a frames per second in RGB, as well as frames per second for the neural network. So that's an example of one of the experiments that you can run, and how you can utilize Jupyter Notebook to really download a model, Also, if you want to convert a model, but download it and then use the myriad command compile to create the inference engine blob. To get out of these experiments, I think they are, you just press the Q button and it ends the experiment. Okay, so that's a pretty good tutorial of the DevCloud for the Edge. So just to wrap things up with this webinar, again, we have a lot of resources available and community support. You can go through these. We're posting all these as PDFs as well, so you can find the links available. There's a number of ways to install OpenVINO directly on your PC, which I do recommend, but the local install is probably the easiest way to do it. And then you can start using demos with OpenVINO. Also check out Luxonis's website, luxonis.com, for access to the DepthAI software environment. It's fully OpenVINO compatible, so you can use our pre-trained models, very similar to how I just showed you, downloading a model. And then also, if you're wanting to learn more, we have an Edge AI certification program. The courses are free. There's only a $99 fee for the certification upon completion, but you are freely available to go through all the courses. There's like six initial lessons and then 3 hands-on labs that use our Intel DevCloud for the Edge. And I do recommend also registering and signing up for our DevCloud. We have Intel DevMesh, which is a project library at Intel. These are our community members, people out in the public who are using Intel technologies, not just OpenVINO, creating projects and documenting them. It's sort of a GitHub, if you will, and they often connect to their own GitHubs, and you can see what kinds of things they're doing. And for any students who are interested in becoming an ambassador for Intel, who want to be an evangelist for Intel technology, we have our Intel Student Ambassador Program. So access to some free software tools, libraries, direct access to Intel DevCloud for the Edge, and early access to information and hardware often available. Visit us at software.intel.com/IoT, sort of the hub for things at Intel related to software and hardware for IoT and for AI. So OpenVINO, you can find the OpenVINO and the Intel DevCloud for the Edge there, and go register or download. And your homework really is, you're ready to get started. Number one, try out Intel DevCloud for the Edge. Also, download OpenVINO directly to your local PC. And so try out both environments. And try out OpenVINO Jupyter notebooks, as well as try out Luxonis's DepthAI experiments. So again, re-review our webinars if you need to. We're looking forward to communicating with you through Slack and seeing the projects that you develop. This webinar will be on demand very shortly. And again, together, we hope we can reimagine how people and data can change our world for the better. Thank you so much. Michaela, are there any questions?
Yes, great. Thank you so much, Jay. This is always so eye-opening and amazing how many tools are readily available just at your fingertips to use and to deploy right away. There is actually one question. I see a question from Charles Griffith, who asks whether the, I guess it's a line that shows up or something. Intel GPU is not detected on this machine. Is that okay?
Was that in reference to, say, a Jupyter notebook or your own? I'm not sure where that line might have been, so I'd have to know where it was to be able to.
Yeah, Charles, I gave you the opportunity to speak directly, and maybe you can quickly clarify that. Oh, he says OpenVINO install happened during an OpenVINO install.
Oh, for you directly, Charles. Well, I think if you have a GPU installed, I mean, if you have if you're doing this on an Intel-based PC, not say an AMD or something else, but if it's Intel-based PC, it should find it. And if you want to go to, I would say, let's see, Intel or go to for support.intel.com/IoT to find our support resources. I would say go to this OpenVINO toolkit website. And I'm searching for the support. Yeah, so here's the support forum for the Intel distribution of OpenVINO. So you can go here and you can search for published, maybe a similar issue has been published, so you can search the community. But you can also, if you're registered, you can submit an issue. You can sort of attach what that output was specifically, and we'll have somebody help you and help determine what your problem was.
Yeah, so hopefully that will help you, Charles. And the other question you had was about slides. Yes, the slides will be available. We will send a note to everyone who attended this training, or even everyone who signed up and could not attend for whatever reason. And in that, we will give you the link to both the recording of this session as well as to the slides. So you will be able to have that directly, and then you can also find it on the websites.
Right, I was going to show that here on Transatlantic.ai Hackathon. So if you go scroll down to the events, so you'll see the training sessions like 1, 2, 3, 4. You can re-review the recording, and then here are the slides. So we're publishing all the slides in PDF format so that you can download them and really connect to the links, because we realize you can't connect to a link over a video webinar.
Yeah, thank you so much, Jay. I hope everyone in the audience will sign up for the hackathon and comes up with a great project. Your creativity is needed for the world, for everything. So please try, find your teammates, and we will also help you to find teammates if you don't have a team yet. We will have a matchmaking session on August 30th. So that information is coming up soon, so that you find your team. Thank you, everyone.